So today we will be talking about numerical and phonetics. We will be talking about numerical phonetics. Now, numerical phonetics before we start with numerical phonetics, there is a term known as character weighing. Character weighing actually means that you are assigning greater or lesser taxonomic importance to certain characters over other characters. So the term is you are giving a greater or lesser importance to a taxonomic character over another character. So the philosophy behind it is that if there are two characters, one character is A and one character is B. Character is, say, something, it can be a morphological character, behavioral character, anything. So you are giving an importance of one character that is more important than another character. So your A may be something like absence or presence of limbs. B may be a character, say, absence or presence of beak. Two characters. Now, you have to take a decision which character I should take first. Suppose there is several types of birds present. So in the bird, when you are talking about a bird, immediately if you consider about A and B, the first thing in bird what you will see is the presence of its wings. If birds don't have wings, then basically it doesn't make any importance in giving bird a character or taking limbs. It's not important. The limbs are not that important. But what is important here is, you know, that wings. A bird without wings is a very bad word saying. That means you have something but तुम्हारे दिमाग में बुद्धि नहीं है. It is saying like this. So in this case you have to take a decision, and your decision will be, you will give B a greater weight. वजन ज्यादा दोगे उसको. अरे somebody calls you on the phone and asks you, sir, I have seen an animal. What is this? Sir, this animal flies. Okay, it's a behavior. Then how do I character? Okay, does it have wings or does not have wings? It does, or does it have limbs or does it not have limbs? I am thinking about a snake, no limbs. But here we are talking now, sir, this has got wings. The limbs, there are limbs, but the limbs are modified as wings. So the first thing you will give B is given a greater weightage. Okay, the first character you have to consider is B. Now over here, Rako, the other students will come, then you put it. So the first character is B. Okay, B. So this decision you have to take yourself, because wings are required for flight, and birds are known for that because they can fly. They don't have wings, so they may not be bird. Even if they have, they cannot fly, they will still have vestiges of wings. So this character, when you are making this phylogenetic tree, here we are using it for numerical phonetics. That is, you are giving numbers to this character, plus, minus, or 1 or 2, or 1 or 0. Present 1, not present 0. You are giving something like this. You are using numbers instead of making a big tree, or giving a number and a table. So B is given a greater character weightage. So this phenomenon is known as character weighing, and this decision is something which you have to take from your experience, right? That which character should I give the weight? So that should be done very logically. This character weighing must be done very logically. You are talking about a bird which is flying, and you are giving the limbs importance. Okay, now I will give another character known as P. That is absence or presence of beak, chonch. Here B will be given the flight is a greater importance. Presence of beak, presence of wings. B will be given greater importance than C. Birds will have a beak. If they don't have a beak, or the type of beak is very important for a bird. A duck has got a different type of a beak. Their feeding habit is mentioned in the beak. So but first thing, it should be able to fly. The wings are present or not. Next character to your experience is wings, beak. And lastly, you can say that this is greater than A. So this sort of a mechanism which you do, this is known as character weighing. This is known as character weighing. লিখে নিন তারপর হয়েছে? The next is definition of numerical phonetics. So it is the methodology. So it is a method. Numerical phenotype. It is a methodology. And what do you do in this methodology? In this methodology, you assemble individuals into a taxa. Assemble individuals into a taxa. You know what taxa means? Taxa means either it is for species, genus, order, family. Each of them is a taxa. The plural. Singular is taxon. The singular is taxon. So this is what you do here. You assemble, you have been given 100 or individual organisms, you don't know which is which. So first word is, you are going to put them into a taxa. Maybe you are putting them into a phyla. You have given plant, you have given some animals, some protozoa. So you are assembling them into phylum. Your phylum chordata, or kingdom. You are putting them into plant, or you are putting them into animal, or you are putting them into monera. You have been given several of them. So in numerical, in this methodology, you assemble individuals into taxa. You classify them. And what is the basis? Yes, a hisab pe you are assembling, taking into character what? On the basis of an estimate of unweighted overall on an estimate of unweighted overall similarity. That is, first what you did a character weighing. I had explained about character weighing. You are giving which character is important or which character is not important. But you are not taking up the weightage of it. Unweighted, एक character बस लिया. On your assumption, you have taken just one character. Unweighted. You have not given this a priority. Okay, B is greater than C, which is greater than A. You are not taking it like this. You are giving an unweighted overall similarity. So, in the overall 100 organisms, say for example, which you have been given, you have seen that this particular organism, 1, 2, 3, 4 and 5, say for example, it can be in anyone, 1, 25, 27, 30, 50, 5 characters you have taken, 5 individuals you have taken. You see that all of them have got wings. So, you assemble them into a taxa known as winged. Forget about the whatever, phylum, class apes or whatever. You see them to be winged. You have not weighed the characteristic, whether beak is important or not, or you have not seen that. But for example, randomly I choose an unweighted character, winged. Then you see another character, beak, limb. Another character you see, say for example, hair on body. You have taken a character. So, winged, you say a plus. Beak, it has got a plus. Limb, it has got also limb. Hair, minus. So, something like this, you are making them into taxa. So, this taxa you can call it as ave. Another taxa, I am writing, say for example, wings minus. It has no beak. It has got limbs and it has got hair. You put them under you can give them as also, you can write 1 instead of plus 1 and instead of 0 you can put 0. Here also you can put 0, 0, 1, 1. So this type of thing, this is what you do in numerical phonetics. Former times this was a very important way of classifying organisms or identifying and classifying organisms. Then we are talking about another term, similarity matrix. Matrix is a score or array of points or numbers or something, one after the other in a particular orientation. They are organized. You can a matrix, you can organize it as X. This is a 3 into 4 matrix. This is a 2 into 2 matrix. You can have numbers over here or scores. You can say a number is a score also. Kitna score kiya? So all your marks, say you have got 75, 45, 35, 100, 90, I can organize the scores. You have got this percentage. I can organize it in a framework. This is a matrix. You don't need to write this down. This is just to understand, make you understand what a matrix is. So, similarity of matrix is it is a similarity matrix is the matrix of scores. This is the first thing. What is the similarity we are talking about? I have rubbed it. It is a matrix of scores. So, some scores are given. It's organized 1, 2, 3, 4, 5, 6, 7 in some manner. That will be given to you. It will be, you have to define. That will be given to you. It is a matrix. And what it does? Matrix of scores. Between two data points. 1 second, before I explain it, I write down the next point. What do? They express similarities. Now, let us talk about a DNA sequence of two organisms. This is organism A. This is organism B. So you will have a similarity matrix. Now let it be, we are talking about nucleotide sequence. You know that DNA has got 4 nucleotides, A, E, G and C. It is the combination of this which gives a particular gene sequence. So organism A, say it has got a sequence of A, T, C, G, G, A, C, A. Organism of this, it has got say T, A, T, G, C, G, A, C, A. Now, what are you are drawing it in a matrix. What is the similarity? This is not a similarity minus. Similarity plus, minus, plus, this is minus, plus, plus. So points of difference are, this is one point of difference. This is the difference. Just hold on. হ্যাঁ চঞ্চল বলো।
কেমন আছো তুমি?
হ্যাঁ ভালো আছি।
ডিপার্টমেন্টে আছো?
হ্যাঁ আমি ক্লাস নিচ্ছি।
ও আচ্ছা, পরে বলবো না।
এটা তোমাদের ক্লাস নয় কিন্তু। আচ্ছা। So now how many sequences are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if they ask you what is the similarity matrix or what is the percentage of similarity, you can say that 3 out of 10 into 100, you get a score of, there is a 30% dissimilarity and 70% similarity. So basically you are organizing it like this in a matrix form. This type of a matrix, for example, is just an example. There are many ways of similarity matrix. This is one example of a similarity matrix. And what is the score of similarity? Some people like to call it as 0.3 and some people like to call it as 0.7. Maximum similarity you can get is 1. This is one way you can go ahead. This is a similarity matrix. So, now if there is an organism C, you write the sequence and see how many similar all among these three. So, if you go, higher scores are given more similar characters and lower or negative scores for dissimilar characters. Here each character is a nucleotide, each base DNA. Higher scores are given given to more similar characters. Higher scores given to more similar characters and lower scores are given to less similar characters. Now instead of ATGC you can take different characters also. Just a small example I will be drawing. Organism A, organism B, organism C. This is character 1, character 2, character 3, character 4. Say this is plus some character, this one has got it, organism has one has got this particular character. Character 2 is another character, plus, minus, plus, minus, minus, plus, minus, plus, 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 plus. এখানে কটা আছে একটা রয়েছে এখানে তিনটা রয়েছে ঠিক আছে so you can give it a score which is similar. So how many characters are there total out of there are 4 characters. How many are plus? 3 by 4. So 3 by 4 into 100, you can say that it has got a 75% of the characters are present. Here, out of 4, you have 1. 1 by 4 into 100. You get 25% of the characters are present. Here, you have 4 out of 4. This is approximately 100%. This is 100%. So you can say that organism A and organism C, they are similar. Since you give it a higher score. This is how essentially you do this similarity matrix. This is just an example. You don't have to do it in your exam, but you have to write it in your exam. I've given this note already. मुझे लिखे ना. So, as per classification rule, individuals are placed in a group or taxa on the basis of similar characters. On the basis of character, on the basis of rules of taxonomy. Taxonomic rules. Organisms are placed in a group or taxa on the basis of similar characters. They are placed on the basis of similar characters. And a corollary of this will be organism is placed in a different group or different taxa on the basis of different characters, dissimilarity. This does not have, so it's in a different group. Something like this. Now, one more thing which you have to do. One question comes, what is OTU? OTU means operational taxonomic unit. Operational taxonomic unit is another way of saying what is a taxon. It is the basic unit of numerical taxonomy. It is the basic unit of numerical taxonomy, on the basis of which classification is done. And this could be a species, it could be genus, it could be order, it could be class, it could be phylum, it could be a kingdom. So each of them is an OTU. So when in numerical taxonomy, you take any one of them when you are classifying. Okay, the first job which is I've been given 100 organisms. I have to first find out, first classify or put them into groups on the basis of the first operational taxonomic unit, that is say kingdom. First I will see plant or animal. Plants go one side, animals go one side. Now let us talk about animals. Okay. About in these animals, who are we going to take? Okay. You are doing a phylum. Phylum Chordata, phylum Annelida, all your earthworm and all these are annelids. Arthropoda, insects and crustacea or prawns and all these on one side. Like this you classify, you put them. On the basis you make these tables, similarity matrix, plus, minus, you do it for each of them. Now you have you have done it to phylum, now you do it in class. Class Mammalia, mammals which have got hair, reptilia, crawlers, creepers, dry skin, birds which can fly, class apes. So like this you do for the next taxonomic unit. Then you select one. So for each of them you do a numerical phonetics. This is how the numerical phonetics works. So this, let us finish this in today's class over here because there are less people, more people come. Next day is very critical, okay? Please tell your friends to be there.